Hello, everyone. So we have been working on Magic Governance over the last 48 hours, and we are very, very excited to show you what we've built. So this is the team. You've probably seen us around. We're quite energetic. And we co-founded Abstract together. And we have had a lot of experience with public goods funding in the Cosmos. And most of it hasn't been that great. We have interchain tooling like CWOrchsphere that we've been shilling like crazy. Props to Nicholas. And we have an interchain application platform where we build or we have this chain agnostic application store, but the problem that we're kind of facing is that if we benefit every chain, then no one really wants to fund us.
And this is a big problem in Cosmos. As I'm sure that many of you are aware, getting public goods funding is really hard. For Abstract, it was because all of our tech, it works on every chain. And so no one chain wants to fund tech that's going to benefit everyone. And a big problem with this is there's no way to coordinate this public goods funding because every single chain is trying to benefit themselves and not the overall interchain. We have fragmented grant programs and every chain wants to be unique. We need interchain governance.
We need interchain governance, guys. And we also kind of wanted to play with our own code. So the technology that we mainly used in our project is called Module IBC. It uses abstract interchain accounts, which simplifies the IBC experience. And we also used Neutron's ICQ, which we will dive into later. So a little background on the Module IBC. Basically, you create an account on your chain, and then you can install a module on it. And then you can create another account that is owned by the original account on another chain, and then also install the application on there, and then the applications can like talk to each other directly. So here's some of the CosmWasm craziness. This is the definition of our contract. It is one contract that we deploy on every chain, and it communicates with itself. So we have the normal like handlers that you're used to, so instantiate, execute, etc. The special ones are the module IBC. So this is where our contract will receive calls from itself, but from another chain. Then we have the IBC callbacks. This is when our contract sends out IBC requests, and then on the acknowledgement, the callback gets called, and we can progress the state. And then these replies were for working with ICQ, as well as the pseudo. So how it works is that I am chain A and Adair is chain B, and we're gonna do a little role play.
Hi, I'm Adair. Oh, you're Robin.
Yeah, so I'm Robin. I'm the IBC app on chain Robin, and I would like to invite Adair. So I can hook myself up to the governance system. So this can be like an on-chain governance that everyone who has a token can vote on. And I'm saying I want to include Adair in my interchain governance. So I am the only member of my DAO. So if that proposal passes, then cool, we'll invite Adair.
All right. I guess I have two choices here, as I am also just chain. So I can accept or deny. So yeah, for this demonstration, let's accept. And now both of us have accepted our state, which is I have Robin and Adair in the state, and he has Robin and Adair in the state as well. Great. So what happens if we want to add additional members, additional chains to this DAO? Nicholas, we're gonna need you up here. But yeah, so Robin and I are in a DAO together, and we can propose that we add Nicholas. Hi.
But when we propose, we ourselves need to get like vote on this proposal as well. So it's either me that proposes it or Adair that proposes it, and then the counterparty needs to vote as well. So they can do a governance proposal on their chain if they want to include this beautiful guy in our DAO. So we do that, and I think we both agree that he's pretty cool. So once we have done the voting, we get the vote details. So one of the contracts can be triggered to reach out to the other instances of it and get the vote details. And then after I got all the vote details, I can start executing the proposal.
So the cool thing about getting these vote details is that one person gets it and from everyone else, and they're like, okay, here are the details, and then they sync it to everyone else in the DAO. So I'm like, okay, I got the vote details. Here you go. Here's the vote details. And then since the vote has been finalized, we can go ahead and execute this proposal, which will invite Nicholas. So, Nicholas, would you join our DAO?
I have only two choices, right? So, I don't know. Let me ask my people, my chain. Do you like Robin? Do you like Adair? Do you? Yes. All right. So it sounds like I accept.
All right, we accept the proposal, and now all of our state is synced because he's accepted it. So Robin, Adair, and Nicola all in one DAO. Woo! Okay. Cool. So,
Okay, some of the hardships we faced is that we wanted to basically get the result from any Cosmos SDK governance proposal, but you can't do that query in a smart contract because it's non-deterministic. So this is why we use Neutron's ICQ to basically tally the votes on Neutron, do the ICQ to get the details of the government proposal, and then we can make use of the weights of that proposal. So instead of the chain being either yes or a no, it can be 60% of the chain, the governance said yes, and 40% said no. We also had some bugs in our tooling. We had to figure out how to sync this data, which was quite fun. And it was really kind of cool.
And I think an important thing to note here is that by syncing state across multiple different chains, we're building a consensus protocol on top of these consensus protocols. And so like it follows somewhat similar to the IBC packet flow where you propose a state, they accept the state, you get the acknowledgement, then you finalize it, they accept it, and then you get the acknowledgement. And it syncs it between all the chains.
Yeah, so future work would be to integrate this weighted voting that I just mentioned, because we had some issues with Starship and Orchestrator. We would also like to add mesh staking, so the weight of your own chain depends on how much money that chain is actually putting into the DAO. Then we want to add more proposal actions so that you can add a proposal to this DAO to send money on this chain to that address, and then other chain to that address, etc. And then just further refining the IBC experience. And I think we're bullish on IBC.
All right, and okay, we can do a quick little demo of a big test that we wrote with 3 chains. So this is using interchain CW orchestrator, similar to the cross-chain governance. We can see that we set up chain A, B, and C. We enable IBC on them. And then we register our governance modules there, connect all the chains. And then A proposes that another chain, I propose that Robin gets added to the DAO. I wait for that IBC packet. I check that he accepted my proposal and that we got the results from those members. After this, to propose to add Nicholas. You can see here, we wait for this IBC packet, and we assert that this state has been proposed. So it's finalized on our chain. It's proposed on Robin's chain. And then we can call finalize. This is the second step in syncing. And this would assert that this state is finalized across all 3 chains. Then we ask each chain for the proposal because this is a pending proposal. It hasn't been voted upon. And we can execute the votes on these 2 chains. We wait the blocks for the proposal to expire. And then we request those vote results. So Once those vote results come in, we can have chain C, which is Nicholas, accept that governance invite. Now that he's gotten the proposal, we can execute it and then check that we have all 3 members. And this test does run. All of the code is functional, and we were about to deploy it, but we ran into some Rust compiler issues. So yeah, anyway, interchain governance.
That is amazing. Thank you very much for the presentation.